Hey there folks, today I will be talking about memory unit of CPUs. So let's consider a CPU which has a memory unit of size 8 cross 16, where 8 corresponds to the number of registers and 16 to the number of bits in each register, which looks something like this when you put it together. Now you see that I have put these little squares in place of bits. What they really are is just a flip-flop circuit to store one bit of data. A flip-flop circuit is a latch combined with clock signal, which basically determines when a flip-flop updates its state based on the latch state. And the little triangle you see is the tri-state buffer, which apart from other electronic devices has a third state other than 0 and 1, that is the high impedance state, which means when the enable pin is on, only then the flip-flop little squares you see are enabled. Now I want you to keep this in mind that it is the enable pin which will help us to toggle on or off the state of each flip-flop or register. In the similar fashion, all 8 registers are paired up. Now the picture of memory unit should be clean in our heads. The question you should ask is how we are going to select these registers, right? At the end of the day, the control unit wants SS of these. So let's figure out what is our mystery solution to select these registers. Well, the answer is a multiplexer. So here's our 8 cross 1 multiplexer. 8 because we have 8 channels, aka registers, which for example will be something like this. With a configuration of 000 on select lines of multiplexer from control unit, it will let the first bit pass through it. Well, that solves the problem for one bit in each register. What about the others? Let's change the view of it so that we can visualize this more clearly. So nothing has changed, same multiplexer, same configuration, and you can see that each bit aka flip-flop is connected vertically in this setup. Now back to the question. CPU wants entire register. This in fact should come from intuition that if one multiplexer was used to select one bit, how about we employ each multiplexer to select each bit and join their output to a common channel, something like this. I want you to carefully look that the select lines at bottom are common to each multiplexer. Only then they all will select the same bit and therefore whole register. Now let's have a quick quiz. What combination the control unit will give the select the following register? So we got 8 registers here, and the number of bits required to address 8 things is the log of 8 with the base of 2, because binary has 2 bits, 0 and 1. And remember I said each multiplexer has same select lines, the ones in blue, so what applies for one applies for all. And obviously the answer is that the control unit will send the combination of 0 and 1 in order to select the 4th register. Hope you enjoyed the talk and thank you for your time.